So in section 1.4, we were introducing angles. Ready, gentlemen? Okay, so 1.4 we were introducing angles. In 1.5 we're going to explore angles a little more in depth. Again, still laying the foundation for a lot of the things we're going to do in geometry, talking about different types of angles. And I can specifically remember back when I took the ACTs to get into college, these were types of questions that I saw pertaining to vertical angles and using algebra. You'll see it here in a little bit, but vertical angles are a big one that they like to ask us about. Here we go, vocab. First one, complementary angles. Angles whose sum is 90 degrees. Anybody know what's called when you have two angles whose sum is 180? Harmony? Supplementary angles, yeah. Now I wish there was a magical way to remember which one's which. Here's the way I used to do it. I'd say, well, 90 is smaller than 180. And C comes before S in the alphabet. That's how I did it. There's probably other ways to do it, but that's just the trick I remembered. Whoa, what's that? What'd she teach you?
She taught us many different things.
What's sup? Supplementary? Give me a compliment? Okay, cool. All right. Sure. Okay. Next one, we've got adjacent angles. Adjacent's a vocab word that we used to do when we had our vocab homeroom program. We used to have this as one of our vocab words, adjacent. It means next to or beside something. So when you have adjacent angles, you've got two angles that are right beside each other. And since you have two angles touching each other, they have to have the same vertex. So looking at this diagram here, anybody think they can pick out two adjacent angles? Alex? 1 and 2. Okay, they're two angles, and they're right beside each other. They share a common vertex. Anybody see any other adjacent angles? Dana? 2 and 3, they're adjacent. There's a couple different sets. 1 and 2, 2 and 3, 3 and 4, 1 and 4. Those are all adjacent angles. They're just next to each other. Okay, we've got a linear pair. When you hear the word pair, what do you think? 2. So we're talking about two adjacent angles with non-common sides being opposite rays. Okay, we'll break that definition down a little bit. When you hear the word linear, what do you think? Line. So linear pair, we're dealing with two, the pair part, two angles that create a line. Anybody see a linear pair up there? Rouse?
4 and 2.
4 and 2? Let's see. They have to be adjacent angles, though. They have to be right next to each other, so that wouldn't work.
1 and 2.
1 and 2? Yeah. Okay. They're adjacent. They're next to each other. They're non-common sides. Well, this is their common side right here. Their non-common sides, there and there, are opposite rays that make a line. Okay. Then our last vocab word here is vertical angles. Now, don't write the definition in blue. That's the fancy definition. Two angles that create two pairs of opposite sides. I like the red definition better because it's shorter. Angles across from one another. Angles directly across from one another. Anybody want to take a stab at vertical angles up there? Donnelly? 4 and 2, they're across from one another. Anybody see another set of vertical angles? Katie?
1 and 3.
1 and 3, they're across from one another. Okay? So a couple vocab words to get the foundation going. What do we got here? I'm going to get rid of my black box. There we go. Example 1, it says identify complements and supplements. In the figure, name a pair of complementary angles. Let's start with that. Anybody see any complementary angles? Kind of a different looking figure. Boyd, what do you see?
ABD and BDC.
ABD and BDC. Yeah, Because if you take 52 plus 38, yeah, you get 90 degrees. Okay. So she said angle ABD and angle BDC are complementary. Okay. How about some supplementary angles up there? Anybody seeing supplementary angles? Roman, what do you got?
Angle ABD and BDE.
ABD and BDE. Why do you think those are supplementary?
They add up to 1.
You got it, okay. So because 52 plus 128 is 180 degrees, like he said, angle ABD and angle, oops, missed my little angle symbol, there we go, angle BDE are supplementary. Very good. Okay, are those the only, is this the only way to write angle ABD? How else could I label angle ABD? Andrew? You could also call it angle DBA. So, you know, sometimes when you're checking your work, if you go, wait, mine doesn't say exactly what that says, it's okay. There might be different names for angles, okay? And then finally, we're supposed to find a pair of adjacent angles, two angles that are right next to each other. Don't necessarily have to form 180 degrees. They don't have to make a line. That would be a linear pair, but do we just have any adjacent angles up there? Yeah?
Angle BDC and angle BDE.
BDC is right there, and BDE is right there. Yeah, those are two angles right next to each other. Okay, angle BDC and angle BDE. So we call them adjacent angles. Now, the little margin here, they give you a little note. It says, in example 1, angle BDE. Let me highlight that one. That's right here. And angle CDE, I'll put that one in a different highlighter color. CDE, why aren't they adjacent? Maybe I'm going to put it in a little different color so they contrast better. Put it in red. Are those angles right next to or beside one another? No, this angle is actually inside of this one, isn't it? Okay, it's like getting gobbled up. So that's why we'd say they are not adjacent, because they share common interior points. All right, there are points on this angle, the purple one, that are inside of the red one. And when you have adjacent angles, you'll never have points inside one another. Like in the one Yacht told us, if you took any point in this angle, it's never going to be in this angle over here. Okay. All right, what do we got next here? In the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. Let's cruise through that together really fast. Somebody help me out. What do you think? Anybody know a pair of complementary? Dana? DEF and ABC. I agree. Why? Beautiful. 50 plus 40 is 90. How about a pair of supplementary angles? Who's got a set of... Farley?
Angle GEF and angle ABC.
I like it. GEF and angle ABC. Again, those aren't the only names you could give them, but that's a possibility, because 140 plus 40 makes 180. Add a pair of adjacent angles. Adjacent. Cuff?
DEF and
Yep.
F and G.
Yeah. Just two angles that are beside each other. Very good. Okay, let's cruise to example number 2. So now we have to use a little algebra. Okay? Given that angle 1 is a complement of angle 2, what does that mean? If they're a complement, what are we talking about? Form 90 degrees. So given that angle 1 is a complement of angle 2, and 2 is 57, how can we find the measure of angle 1? What do you think, Dana? Yeah, together they make 90 degrees. So if we take 90 minus what we know, I suppose that's what they wanted here. Okay, 90 minus 57 is going to give us what, 33 degrees? Okay. I think officially they wanted me to do this. Measure of angle 1 is 90 minus the measure of angle 2. I guess that's the fancy way of writing it, but we get it. 90 minus 57, right, Roberts? That's the key. How about B? It says given that angle 3 is a supplement of angle 4, and we know angle 4 is 41 degrees, how can we find the measure of angle 3? What do you got there, Willard?
180 minus 41.
Yeah, 180 minus 41. Together they make 180. We know this one's 41, so subtract. I think we're going to get, what, 139? Okay, very good. All right. Now notice the difference here. When you talk about the measure of an angle, you put a little m there. Okay. Talk about the measure of an angle, then you'll label it in degrees. Okay, we're going to skip this and this because you guys have a good handle on it. Let's jump to example 3. Now we get to use a little algebra. Basketball pole forms a pair of supplementary angles. That throws off a little red flag. Supplementary, right? What's up? Is that what you said? How many degrees is that? Supplementary, 180. So if we know 180 degrees is the sum of the measures of supplementary angles, we know that these two angles added up are going to be 180. What algebraic expression am I going to have to set up? What algebraic equation am I going to have to set up to try and solve what x is? Roberts?
3x plus 8 plus 4x minus 3 equals 180.
Yeah, if I add the two angles together, I better get 180 degrees. So now we just have to use some algebra. How would you simplify the expression on the left side of the equation? By combining like terms, what would we end up with? Brady?
7x plus 5.
Yeah, because the 8 plus the negative 3, 8 minus 3 is going to be 5. Good. Okay, now we're down to a two-step fence post problem. We'll subtract 5. Divide by 7. And bam, we've got x equals 25. We want to make sure we answer the question though. It said actually find what those two angles are. We did the hard part, we found what x is. Now we just have to plug and chug and evaluate to figure out what they're going to be. So we've got BCA, that was 3x plus 8. So we've got 3 times 25 plus 8. What are we talking? 83 degrees? Okay. Now I could go through all the algebra and figure out, 4 times 25 minus 3. I'm not going to write it out. What's it going to be? What's another way I could have done it without doing all this? And said, what's 4 times 25 minus 3? What's that?
Has to be 100 degrees.
Has to be 180 degrees. And if this one's 83, well, this one's got to be 180 minus 83. Hey, it gives us the same thing. Okay? So we've got our two angle measures. All right, this is the same type. I'd rather have you guys have some homework time. So we're going to skip this checkpoint problem. Come to example 4. Identify all of the linear pairs and all of the vertical angles. Okay, let's see. What do we got? Anybody see any linear pairs? Two adjacent angles that make a straight line. What do you think? Boyd, you got a set?
2 and 1.
2 and 1? 2 and 1. Angle 1 and angle 2. This is the second part, huh? Angle 1 and angle 2, yeah. Anybody see any others? Farley?
2 and 3.
Angle 2 and 3. Anybody see any others? What do you think a common mistake you might get is? 1 and 4 is usually, or 1 and 5. Sometimes people make that mistake where they'll say, well, here's a straight line, and it's angle 1 and it's angle, oh, wait a minute, it's not angle 4. It's like a combination of angle 4 and 5, so it's more than 2, so that's not a linear pair. How about vertical angles? Anybody see any vertical angles up there? Directly across from one another and are equal? Hager?
3 and 1.
3 and 1? You got it. They're directly across from one another and they're equal. 1 and 3. Equal angle measures. Okay. We can't say 2 and 4 because do they mirror each other? No. Okay. They're not directly across. If it was If this was one angle, yeah, they'd be vertical because they'd be directly across from one another. Angles form, I don't know what they're looking for. Okay, we're going to skip that. Last example. Two angles form a linear pair. Red flag, 180 degrees. The measure of one angle is 4 times the measure of the other. Find the measure of each angle. Sketch a picture. If this is x, just from the information they gave us, what's the measure of this one? 4x. They said it's 4 times as big. So then how could I set up an algebraic equation to solve for x? Campbell? Okay, not 90, but
180.
yeah. If we take x plus 4x, we're going to, oh, I'm sorry, I thought you said 90, okay. The measure of the other angle, okay, is 4x. Boom, boom, boom. So we get 5x equals 180. Divide by 5, what do we get? 36? Is it 36? 36. Okay. X is 36 degrees. Well then, if I need to find the measure of the other angle, I'll just take 4 times 36, or I could take 180 minus 36. What are we going to get? 144? The measure of the angles are 180. There. I don't want to be restricted to filling in the blanks. I paved my own trail. Okay. Let's quick fill this in, make sure we kind of review it all here. Summarizing all the different things we've talked about with angles and lines. Points A, B, and C are what? If you got 3 points, what do we call that? They're with each other on the same line.
Collinear.
Collinear. They're with each other on the same line. Okay? All points shown are
Coplanar.
what's that?
Coplanar.
Coplanar. Excellent. Okay, they're on the same flat sheet of paper. AC, ray BD, and BE blank at point B. They all crash together. They all intersect at point B. Very good. Okay, angle DBE, that's this one here, and angle EBC, that's this one here in orange, are blank angles. Blank angles. Malinsky?
Complementary.
Complementary. Boy, they don't give us a lot of room, do they? An angle ABC is a, yeah, I heard somebody say it, is a straight angle. Okay, let's finish it up here. Point E. Point E lies in the blank of angle DBC. Point E lies in the, boy, it's inside of that angle. What's another word for inside? Interior. Yeah. Okay. Now, here's a little, hey, you might get fooled, but in the diagram above, so right here, you cannot conclude that AB is, what does this little symbol mean right here? Congruent. You can't say that AB is congruent to BC. You can't say that angle DBE is congruent to EBC, or that ABC, or what is it, ABD is a right angle. They don't say that here. It might look like it, but we can never assume. The only way we can tell if this distance is congruent to this distance, if it's marked with a what? Line. A little line like that. Same thing with the angles. Hey, Mr. Hilliard, they look like they're equal, so I'm going to pretend they're equal. You can't assume anything. We have to assume that they may be different unless we're told differently with the arcs, okay? All right, you guys have the tools you need for 1.5.